Hello and welcome to the ANZ Summit. My name's Stephen Leedig and I'm a Serverless Specialist Solutions Architect with the AWS Serverless Computing team in ANZ. I'm very excited to be talking to you today about three of my favourite topics: serverless, event-driven architectures and Amazon EventBridge. This presentation makes some assumptions about your knowledge of EventBridge. I'm not going to be covering any of the basics about what EventBridge does. I'm assuming you already know about event buses and rules and targets and features like the schema registry. What today's presentation is largely about is an exploration of what it means to design a serverless event bus as a core component of your application integration. I want to share with you some of the common themes that come up when I talk to customers about using event-driven approaches to integration, and some key design decisions that need to be made when planning for organisational-wide adoption. This means understanding core concepts around coupling in a distributed environment and choosing the right events for the architecture at hand. It means understanding the roles and responsibilities that event producers and consumers have and how they relate to EventBridge. And finally, I want to share with you some thoughts about what you need to plan for as you go about designing a serverless integration using EventBridge. Teams building microservices architectures often find integration with other applications and external services can make their workloads more monolithic and tightly coupled. It can also be challenging to work with large amounts of data in different data stores and locations. This is why customers are looking at event-driven approaches to integration. It helps them decouple their applications, allowing for logical decomposition of business functionality. It's helping them achieve process isolation, which can be scaled and monitored independently of other components. And this isolation also provides a blast radius, so issues in one part of your system minimize the impact to the rest. However, moving applications to the cloud or building cloud-native applications fundamentally means that you're adopting a distributed architecture. And this means that we need to think differently about lots of different things, such as how we manage dependencies, encapsulation, and coupling. And if you're like me, one of the things that is constantly hammered home to you as a software developer is that you need to have loose coupling and tight cohesion. But when you take a closer look, you realise that there are multiple facets to coupling that we need to consider when designing our systems. Ultimately, we need to appreciate that coupling is a function of multiple dimensions and that there are no loose or tight coupling. It's a matter of making appropriate trade-offs. And like Gregor Hoppe says, it's dependent on the level of control that you have over the endpoints. But not all coupling is bad. Having no coupling is just as bad as having lots of it. If you have no coupling at all, you're not interacting with anything and nothing is interacting with you, and that's not particularly useful to businesses. This leads me on to a quick but important discussion about events. In almost every presentation I've given on event-driven architecture or EventBridge, I've included this slide with this definition. An event represents a signal that a system state has changed. And while this is technically correct, it's a little bit more than that. An event can also be defined as a contract for integrating system boundaries. Thinking about events in this way supports the idea that we're dealing with business-level interactions that are established on the basis of making commitments to contracting parties, and that there's an inherent level of trust between producers of the events and their consumers. Like coupling, which is multifaceted, events come in different shapes and sizes. A lot of the time when I hear people talking about events, there isn't much of a distinction made between one event or another. It's assumed that we know what the intended application is. And I've fallen into this trap myself. Understanding the different types of events will help us recognise where and when to apply them in our architectures. Martin Fowler identifies three different types of events which are really useful definitions. Notification events, which are basically that signal I just talked about in my definition. They notify us that something important has happened, but generally don't have a lot in the way of information and are void of context, which typically needs to be provided by the event consumer if they need more information. Event-carried state transfer events are a type of event we consume when we want to capture changes in data. Think about events that are generated from a DynamoDB stream. These events hold a delta of the changes made to items in your table and are really useful for updating consumers' local copy of information they are storing in their own data stores. The domain events is really a combination of both, and with the express difference is that they are intended to be self-contained. They are modelled as close to the domain as possible and include all the context necessary for consumers to process them without the need to query a source for additional details. The event type that most closely aligns with EventBridge events is the domain event. Its structure allows producers to add context to the events that they're publishing. Uniformly describing events in this way is fundamental to integrating your systems. Irrespective of the type of system that produced the event, this could be a custom application you're building, an AWS service event, or an event that is generated by a SaaS application. All events are structurally the same and can be handled in the same way. Understanding who owns what in EventBridge is probably one of the most common questions I help customers understand. So let's dive a little bit deeper and talk about the roles and responsibilities of events, of event producers and consumers, and how it pertains to resource ownership. Publish-subscribe patterns are essential to what we're implementing with EventBridge. In this pattern, we typically have one logical publisher for a given domain event. They may be physically distributed across multiple execution environments, but logically they're all publishing the same event, and there will be one or more consumers. There are no point-to-point connections between system boundaries, and this helps us address the multiple types of coupling we discussed earlier. But we don't want to remove all the coupling. The good coupling, the stuff that supports our business interactions across system boundaries, is what we want to promote. By subscribing to a particular event, we establish a contract between the event producer and the event consumer. These contracts can be established formally through EventBridge schemas. These specifications describe the structure of the event and can be used to discover, validate, and share events across your organization. And as I'll show you later, customers and open source contributors are using schemas in really interesting ways. Producers should also care about who they enter a contract with. There needs to be a business justification for an application to consume an event. After all, there is a cost associated with building that integration. Producers should therefore put some controls around who can subscribe to events that they are publishing. Now, with the contract established, what then are the producer's responsibilities? Well, fundamentally, producers make a commitment to publish what they say they're going to publish. Any deviation from that violates the contract. This includes ensuring that as event structure or schemas change, that there's a consistency across system boundaries. Now, once an event is defined, it typically will not change very often. When it does change, a new contract needs to be defined, which also means consumers need to provide new event handlers or update existing subscriptions. This also means, for a period of time, event producers may need to publish two versions of an event to make sure that they can support new consumers, while at the same time maintain compatibility with existing subscribers. Ultimately, publishing multiple versions of an event isn't a sustainable activity for producers and can add additional complexity to your solutions. But knowing who is subscribing to a particular version of an event provides producers a safe way to encourage those consumers to migrate to the newer version of the event with the view of retiring the older one. Finally, it's the producer's responsibility to ensure that they send events as close to real time as possible without consideration of who or how those events are being processed. Now onto what producers are not responsible for. Producers make no assumptions about how consumers are processing their events, or if they're being processed at all. As I just mentioned, producers may be interested in who is consuming a particular type and version of an event for the purposes of understanding impact that any change that they make might have on the rest of the system. But taking into consideration the constraints of a consumer might have, for example, the rate at which they can process events or their transformation needs, introduces a level of coupling that we're trying to avoid in the first place. These considerations are really the responsibility of the consumer. Consumers determine how the events that they are subscribing to should be routed. This includes defining an event pattern and selecting the appropriate target that best suits their application needs. And this is very domain specific. Luckily for you, we have 28 service integrations that make this super easy. Consumers also need to make sure that they're able to process the events at a rate that is suitable to them. This means ensuring that they have sufficient scale to process the events, or introduce a durable buffer such as Amazon SQS queues to rate control event ingestion. This, in my opinion, is the preferred approach in most cases because it also provides you a means to recover from failure and provides a transactional boundary that isn't dependent on the features of EventBridge. Equally, any transformation needs a consumer has are specific to that application or service boundary. These are not things producers should concern themselves with. Which brings us to EventBridge's responsibilities. Among the many features it has, fundamentally it provides a common set of APIs that allows you to manage service features, as well as securely publishing and subscribing to events. And like all AWS services, it does so over a non-proprietary protocol, namely HTTPS. So how do we map the responsibilities of producers and consumers to the EventBridge service capabilities? Most of the responsibilities that producers have happen before any event is sent to an event bus. One of the first things that needs to be established is setting the appropriate permissions to allow producers to send the event to the event bus. Event producers also own the schema definition that defines the event contracts and the permissions that determine who can access schema registries and use schemas. In order to maintain a decoupled relationship, consumers essentially need to own the rules that process the events that they subscribe to. This includes defining event pattern, the targets that will be processing the events, any additional transformation needs, and custom retry policies and their associated dead letter queues. For this to work, however, the producer needs to set the appropriate policies on the event bus to allow the consumer to manage the rule, thus establishing a contract. Now that we have a clearer understanding of who owns what, let's take a look at how you can start to think about putting all of this together to design and build an event bus that forms a central part of your integration strategy. When I was thinking about how to best communicate my ideas and put them into a format that captures many of the concepts I think are important to consider when designing event-driven integrations, I started out with a mind map. Turns out this is actually a pretty useful tool, so I thought, why not share it with you today? Our discussions so far have been largely around producers and consumers, but there are other categories I thought about that are just as important, and this includes things like events, which really are at the heart of our integrations. Governance is also a critical piece of the puzzle, and is as is the evolving topic of discovery. So let's take a look at each of these in detail and dive into a few specifics along the way. Events are at the heart of integration, so putting some structure around how you describe events once they've been defined is really important. The key to doing this, I think, is through a consistent, conventional approach to naming. The source and detail fields are a really important part of uniquely identifying an event. You should be able to look at these fields and identify where the event originated from without looking at the data. Think of these fields as a composite key almost. So when you have two events that have the same detail type across different system boundaries, you have a source to clarify the event context. But you're probably thinking, what's the big deal? Why even bother? Just let everyone loose and let them create their own names for these things. But think about everywhere that these fields appear and how much easier it is to subscribe to events or put security policies around their usage if you have some expectation around how they're named. What about observability and governance? You're likely going to be tracing events and logging events as they flow through your system and potentially generating metrics on them too. Having some consistency around naming makes this a whole lot more manageable. Another common approach customers such as Lego and PostNL are taking to extend the context of the events is including a dedicated metadata field that sits alongside the event detail. This is really useful for adding fields such as immutable event identifiers, physical or geographical data, or information about the order the event has in a specific sequence or batch of events. And bear in mind, though, that this metadata object needs to be stable, almost an extension of the EventBridge envelope, as it will form part of the event schemas that producers publish and consumers route on. Producers need to enforce the integrity of the events that they are publishing and make sure that the event meets the definition of its schema. This includes defining and adding metadata objects consistently with each event. Typically, the metadata object isn't something that is modeled as part of the domain. It's more of an integration object that we add to event data to provide more context. The challenge with this is that every producer now needs to know how to create this object when it publishes the event to the event bus. Producers would need to know how to apply business rules, such as validation of event fields or enforcing naming conventions. And putting the responsibilities of implementing this on teams across your organisation seems to me prone to error and not very scalable. This is where you might want to think about creating reusable libraries and utilities that you can share across your development teams. These libraries abstract the implementation details of not only constructing event metadata, but also the fact that you might be using EventBridge altogether by abstracting the AWS SDK. One of the key activities integration teams could be supporting is the creation of these libraries for all the runtimes your organisation uses. This in turn could be centrally managed and distributed through private package repositories. Let's take a look at a simple example written here in C# of how this might be achieved. This customer-made preferred event is a domain event that signals a customer status change. It has some basic information about the customer, such as the customer ID, and a date and time that represents how long they've been a customer for. Note that it doesn't have a metadata property. To model this for every event in the domain doesn't seem practical or reflect what's actually happening in the domain. So how do we go about publishing this event with metadata attached? The first thing we do is create an interface for a utility to implement. In this case, the utility library defines a generic interface called iPublishEvents that takes an event class along with some details about source, detail type, and which event bus to publish the event to. You could further optimize this by removing the non-event specific parameters and provide a way to initialize these parameters in the implementation, but I wanted to keep them here for clarity. The detail and metadata class represent the JSON object that will be sent to the detail field in the put events API call we make to EventBridge. When a new detail object is created, the event is assigned the data property, and the metadata property is automatically initialized with event ID, event time, and a location property. With the classes and the interface defined, the caller simply needs to create a new customer-made preferred event and send that to the utility via the publish event method. This implementation abstracts the use of EventBridge SDK and takes care of creating the required detail property with our event data and metadata. Let's move on to the consumers. Just like the naming conventions are useful for events, the same is true for the rule names that consumers put on an event bus. Again, consistency is key here, and coming up with some conventions around how you name rules will make managing them a lot easier. As an example, you may use a consumer's domain name as a prefix to the rule. This then groups all rules for a consumer together when you describe rules on a bus. As previously mentioned, know your ingestion rate. If you have specific performance requirements, make sure your targets can scale appropriately or put a buffer in to control the rate of ingestion. This actually might come in handy even if you don't have any processing SLAs as a way of controlling scale and costs. From a validation perspective, if you have a need to validate incoming event structure, look to schemas to help you do that. This may be more relevant to interpreted languages like Python that don't have strong typing. But be aware that if you do validate against schemas in your registry, not to make direct calls to the schema API, as you'll likely get throttled. Instead, download schemas locally and only update them when a new version of a schema is published and you need new implementation. Note also that schema validation is a prime candidate for reuse and something that you can build into a shared library, so developers don't have to reinvent the wheel every time they need to validate a schema-backed event. Because we are communicating in a distributed way across system boundaries, we're subject to things like the CAP theorem, in that we have to choose between consistency and availability and the effect that partition tolerance can have on the version of truth each system either side of the partition has. In the event where we do get a partition due to some network failures, for example, an event is sent to a target and processed successfully by the consumer, but the acknowledgement or response is never received by the producer. The producer will likely attempt to resend the message, thus causing the consumer to process the message twice, and this can have unintended consequences on the consumer side. Therefore, we should build consumers with idempotency in mind. Idempotency means that the consumer can receive the same event twice, but will have the same outcome without any side effects as a result of duplicate processing. And there are a couple of strategies for achieving idempotency. One popular way is to define an idempotency key. In this example, we could use the event ID that we sent in the event metadata we created earlier. This provides us a way to track the idempotency state in an external data store. Another important aspect of managing this state is determining the length of time the idempotency is evaluated. For example, if you look at the Amazon SQS and SNS FIFO implementations, there is a deduplication window of 5 minutes. Setting this time is really about finding a sweet spot between a time frame that constitutes uniqueness and a performance of your system. And you may want to consider more or less time depending on your use case. So how does this actually work? What I'm showing you here is a diagram from the idempotency utility in the AWS Power Tools library for Python, which you can use as a reference architecture or embed in your functions to make implementing an idempotency solution a little bit simpler for you. In this implementation, an event is being processed by a Lambda function, which includes the idempotency key. The function checks the external data store to see if the key exists, and if it doesn't, it records the fact that it's processing that key, handles the event, and then persists the result in the data store before returning it to the caller. In the event that the result cannot be returned, the caller retries the delivery of the event the second time with the same idempotency key. This time, the Lambda function checks the data store, sees that the event has already been processed, and returns the stored result to the caller without handling the request. There is also another article that you can look at called Making Retries Safe with Idempotent APIs, which is available at the AWS Builders Library. This shares insights from AWS engineering teams on how to deal with idempotency, which I encourage you to look at. Governance is also a big part of managing your event bus integration. There's a lot more to this than I've been able to brain dump here today, but here are a few takeaways. Observability is key to operational success, irrespective of the type of application or integration you're pursuing. We've published a lot of articles, documentation on serverless observability, even provided a serverless lens as part of the well-architected program we offer customers. Now with AWS Power Tools, we've translated some of these best practices into reusable utilities that you can use for tracing, logging, and metrics. I've already mentioned a couple of times the value of this reusability and how consistency and convention play a big role in supporting that. With X-ray support for EventBridge, you can also begin to trace events as they flow through your integration architecture, providing you with further insights into the health of your system. And using services like AWS CloudTrail, you can build automation around enforcing company standards to ensure consistency is maintained over time. There's also a lot of discussion today around event discovery, cataloging, and describing events for consumption across the organization. Some of these capabilities already exist with EventBridge via schemas in the schema registry. I've spoken at length of the importance that schemas play in establishing integration contract between system boundaries. They not only help us understand the structure of events, but they also help us understand the relationships applications have with one another, and through versioning help us more easily identify their dependencies. There is still a lot to do in this space. One of the core capabilities that we want to develop as an industry is encouraging the real-time flow of information across organisational boundaries and do so through self-service mechanisms. We're now seeing the AWS community building open source tooling built on EventBridge to achieve these things. One such example is an open source project by David Boyne called Event Catalog. Once deployed, this tool transforms your event schemas, rules and targets into documentation. It provides extensibility to further annotate your event catalog with code samples, and even provides visual representations of how events are connected, mapping producers to consumers. These are really powerful features that can help the teams better communicate and understand their integration architectures. And I recommend you check it out. And thanks to David and all the other community builders for your contributions. This is where my mind map journey ends for today. There's still lots to do and think about, but I hope this has provided you with some guidance and better understanding around how you use EventBridge as a core component of your serverless event-driven integrations. I'll leave you with a few key takeaways from this session. There are many different aspects to using EventBridge. Understanding the importance of events, the roles and responsibilities of producers and consumers, and how they relate to EventBridge features is super important. Think about how you can use custom-built libraries or use the AWS Power Tool library to make it easier for developers to be productive and take away the complexity of dealing with common programming challenges like publishing events or building idempotent consumers. And look to conventions to better manage your resources and deal with automation and observability. And continue to challenge yourself and us around building sustainable, discoverable capabilities to support your event-driven architectures. Here are some additional resources for you to review after this presentation. And please take a look at these training resources to continue your cloud journey. Thanks for listening. We really value your feedback to help us improve our sessions, so please share your out of 5 rating. Thank you very much.